there are probably significant subsets of people for whom their brains are reacting in what we call abnormal ways, but from an evolutionary standpoint, they're functioning exactly the way the brain was designed to function. Because evolution didn't care about how well you felt getting up in the morning and how happy and satisfied you were with your life. It cared about keeping you alive.
Hello and welcome to Idioms of Normality on Future Framed TV, the collective podcast series of Traces&Dreams. I'm your host, Dr. Paul Mason, and I'm joined today with Dr. John Richters from the USA. Dr. Richters, thank you so much for joining us.
I'm delighted to join you, Paul.
And I invited you, obviously, because you've written about normality. You've done research on social concepts of what we consider abnormal. Tell us what are some of the perspectives and experiences that brought you to this question, to these ideas?
I started my work on normality at a very young age. I had a misspent youth. I was arrested a lot and accumulated an adult felony record by the time I was 19, I think. And eventually worked my way out of that and ended up working for the National Institutes of Health after I got my PhD for 22 years. So, which some people consider a move from the criminal life to the federal government, a lateral move at best, but it worked well for me. And it allowed me to, having done my empirical work, as it were, as a criminal, to study it scientifically. And a lot of what I have written about and done research on concerns normal and abnormal development and psychopathology and so forth.
You talk about it in a very light-hearted manner, but and hence why you're making me laugh. But on a very serious note, that's quite an incredible journey to have gone from someone with criminal convictions to then moving their way through into academia, doing a PhD, and then working for the National Institutes of Health. That's quite a remarkable journey.
I was exceptionally lucky. I had a number of people along the way take me under their wings. I met the right people at the right time, and it's rather extraordinary. I've had a number of people since that story became public, which is decades ago now. A number of people ask me, suggest that I do some motivational talks for kids at high schools and so forth. And I've always been reluctant because I don't want them to get the message that it's okay to screw up because it'll all work out in the end, because I am a statistical outlier, because the odds are for a variety of reasons having to do with society's perceptions of what's normal and not normal, and things that are taboo and so forth.
I really appreciate what you're saying there. It's very thoughtful and reflective, because often when people ask someone to do motivational speeches, it really reinforces the idea that you can become a self-made entrepreneur. You can become it's all up to you. It's entirely what you do and how you approach life, and it's your discipline, your perseverance that can make it. And what you're suggesting is, well, actually, there's a lot of contextual features that you need to take into account. There's things there's luck, there's chance, there's having the right mentors around you, having all these structural features that.
And I think there's something else too, and that is, and this occurs to me whenever I read these self-help books, 10 famous people, how they became successful, and TED Talks and so forth. There's no reason to believe that those people have any in-depth understanding of how they succeeded the way they did. Their only advantage over everybody else looking at them is they are the best historian of their own lives because they've been there all the time. But beyond that, I'm not sure that people really have genuine insights. I can piece together a story that makes sense to me, but I'm not confident that if I thought I had something insightful based on my experience to pass along, I think I would have, because I do, that's what I do for a living is I write, I think, and I write. So, but I haven't thought of a kind of a hook, a message that, except to say it takes an awful lot of luck.
And talking about your writing, your publishing record is quite prolific and impressive. And I'm sure we're going to get to that when I ask you the next question, which is the central question for the series. And that is, what is normal?
There are two broad categories, two broadly different ways of thinking about normality. One is the pure statistical sense, in which case you can you imagine almost any behavior pattern, any characteristic, human characteristic. You imagine a bell curve, then you can pick somewhere in either tail of the distribution and say from that point on we will call it abnormal. I don't like the word normal, in fact, beyond it's actually misused in statistics too. But to use it outside of statistics, it is almost always so loaded with assumptions, it's not useful. We don't even have a lexicon for talking about the kinds of things that should be paid attention to when we talk about. There is so much information we're exposed to minute to minute, hour to hour, day to day in our lives, that our brains necessarily have to chunk. Our brains filter in ways that we're not consciously aware of, and they do some initial lumping, classifying people, because that's the only way you can get by in the world. You've got to key on certain factors. And if somebody learns that you have a criminal record, for example, that puts you in a category that's got not many good things, nothing good associated with it. Obviously, my value system has changed because I didn't have one doing my crime on the streets. I think the only thing that's changed over time for me, and this gets back to the question of what's normal and abnormal. My behavior was abnormal then, but the core personality traits that played a significant role in my getting involved in that stuff, I still have them. I just learned how to manage them. A lot of my acting out as a kid, as I look back, and I'm going to contradict what I said earlier about insights, but just in terms of pattern recognition, I was reacting against a domineering father, which is pretty common, and there was some attention seeking involved in it as well. But my basic traits of kind of defiance, I wasn't diagnosed with ADHD until I was designing a nationwide study of clinical trial, the first clinical trial in history of children getting methylphenidate, diagnosed ADHD children getting methylphenidate versus a psychosocial intervention versus both, versus neither. And it was in the process of designing that study in the group, as we were working out what diagnostic criteria we would use from the DSM and so forth. I said, this is crazy. I've been like this all my life. And I arranged to have a colleague write a prescription for me to have the formal day-long assessments with a psychologist at NIH. Everything in the final report confirmed what I already, they just kind of formalized what I knew myself. But here's the thing that gets us back to the normal. The psychologist, who's very experienced at this, in her report, she tried to reconcile the fact that my brain functioned in certain ways that were unusual in terms of, I'm very good if I'm terrible at rote memory, I always have been, but if I have something conceptual to wrap my head around, that's my leverage point, and I excel at that. So she determined in her report that the only way she could reconcile my functioning deficits on those tests with what I was currently doing for a living, which was a psychologist for NIH, was what she euphemistically called a new process. The only way she could make sense out of it is, this must be something that happened recently. It's a euphemism for a possible tumor or something. In other words, it was inconceivable to her that that if I had these deficits going back to childhood, that I could have made it to doing what I was doing for a living. And I explained to her, no, I've been like that all along. But I took her up on her diagnostic recommendation, and I got the MRI, and of course it revealed nothing. Whatever is wrong in my brain, and I don't consider them wrong, I just consider them traits. I mean, there's certain, I have a certain kind of ways that my brain functions, and I play to my strengths, and I try to avoid things that, that don't play to my strengths. It's just simple skill stacking. You're familiar with that concept, right?
What is skill stacking?
It's a great concept, and it's a simple one, and it's, I think there are some recent articles about it. It's been around for decades, but there's some recent articles, beautifully written, that I think ought to be required reading by every teacher and every school-age kid in the country. People tend to, it's natural in most contexts as people go through life, to be comparing themselves with other people. Oh, this person is smarter than me, this person is, and what is missed there is that you may not be the smartest person in your group. You may not be the most outgoing, you may not be the best writer, but in my case, I think of my successes, to the extent that I've had them, have really been skill stacking. I have a certain combination of natural defiance, resistance to authority. So I naturally question things, and I don't take simple answers without careful scrutiny. And I don't learn new things easily because I have this distractible brain. I will, for example, in a statistics course in graduate school, I struggled with that initial statistics course more than any other student there, because I have a need. My brain wants to understand something before it takes it in, which is a real obstacle to learning certain things, because your job as a student often is just taking the stuff in and being able to. But so I had to struggle more to master that material. But when I did get there, I understood it at a level of depth that exceeded the understanding that students had who got it right away. To me, I can't imagine my life without that virtue. There's a certain obsessive compulsiveness to it. People tend to think of those kinds of being a little too obsessive and so forth as good or bad things. I think they are features of the way my brain functions, and I harness them. I wasn't good at harnessing them as a kid, but I did eventually get. I didn't understand this business of skill stacking, but I just happen to have a particular combination of skills that makes me unique and particularly well suited for things that people who are smarter than me, who work harder than me, that write better than me, aren't in a position to do. It's just it's like most of the ideas that I have and that I write about, I think of actually as almost being out there in the ether. And I just happen to have a particular set of skills that they're out there for other people to find. But I just, because of my peculiarities, not abnormalities, but just unusual trait combinations, I see things differently. And I know that's the same with you and your work.
I have an affinity for what you're saying, actually. It's helping me unpack something that I went through when I was at university, which is I did a biomedical science degree, was my first degree. And I think 78 of the 80 people I studied with all wanted to do medicine and become doctors. And that was their goal. That wasn't my goal. I wanted to become a neuroscientist at the time, but I really struggled to do the stuff that they were doing. And that was just learn everything by rote, regurgitate it on the exam, and get really good marks. Whereas I really had to trudge through things. Funnily enough, the story about statistics, for me, my entry point into really developing a depth of understanding about statistics was learning about the history of statistics and learning about the people who came up with these ideas and the reasons that they came up with these ideas. Like
Right.
the story behind the p-value helped me understand why this arbitrary number was suddenly decided upon. And and why it was useful at the time and why we should really throw it out now. And talking about the statistics, I want to ask you, you mentioned very much earlier, normal is often misused in statistics. Now, I agree entirely with you that it's problematic when the word normal escapes the methods section or the discussion section of a research article. But I'm very interested in unpacking the ways in which normal can be misused within statistics and mislabeled, perhaps even.
The sense in which it's misused that I'm concerned about, which is probably off topic for what we're talking about, has to do with the assumption, and this dates back to before the 18th century, and that is that if some characteristic, some feature, something that you measure repeatedly, if those scores form roughly a bell-shaped curve, then there is a common cause responsible for for that distribution, and that's what accounts for the mean. And the variation around the mean is just the kind of errors of various kinds that cancel each other out. And there are a narrow range of circumstances under which that's true, but there are many things in life that approximate normal curves that have nothing to do with an underlying cause, a single underlying cause. But that's a pervasive assumption of a lot of the statistics.
This is not off topic for me at all, because I think it is a core problem of our understanding of the universe. Like when you talk about ADHD, for example, or when you talk about what makes a person, let's say, functional, if we don't want to use the word normal in society, there are multiple different pathways for people to end up in the same circumstances.
Oh, absolutely.
And yet when we standardize that data and then make an assumption that there is one pathway that leads to that one outcome, then we homogenize that data in ways that compromise our understanding of the system.
What you're just describing is the dominant paradigm of the social and behavioral sciences. And it goes back, well, in the case of psychology, American psychology, almost 100 years now. I have a number of colleagues who are, in addition to being researchers, I'm talking about psychology, are also clinical psychologists. And they recognize instantly, they don't have to be convinced, that for any given characteristic of behavior, what we call ADHD or conduct disorder, which is the formal psychiatric diagnosis for what in other fields is called delinquency, it's a close cousin, and for depression, you name it, any characteristic of human functioning, there is no fixed path to it. We all understand instinctively that there's no single reason why people donate to charities. They can do it for noble reasons. They can do it for selfish reasons. Think, for example, of Bill Gates and John Gotti as an example, or Al Capone. They're doing it for total, and there are other people who are charitably disposed toward other people, or empathic toward other people, but they don't have the resources to donate to charity. They may have the same kind of disposition toward humanity, but they act on it in different ways. They may become teachers, they may be involved in charitable organizations, they may just be nice to people around them day to day, or they may have this charitable disposition toward other people and feel an obligation to humanity and so forth, but not act on it because they also have competing psychological, characteristics that are essentially blocking it or that trump that trait. It's hard to imagine anyone who doesn't believe what I just said about most things. Yet the science is predicated on the assumption that for any given characteristic of behavior, ADHD or depression, that there is a single underlying combination of causes, and that combination is the same combination that explains your depression and my depression and everyone else's depression. Nobody believes it, but the methods that they use presume it.
If we were to theorize about this, is this related to what you've written about in your research as equifinality or multifinality?
You know, most organs of the body are encoded in the genome. The heart is genetically coded. Everyone with a normal heart, their heart isn't. The reason when you go to a doctor and you have an annual checkup, he doesn't spend the first 20 minutes trying to figure out what organ is pumping the blood and where it is in your body. It's in the same place in every normal, statistically normal body. It always pumps blood, and it always does it in the same way. The way the heart functions, the way it pumps blood in coordination with other systems of the body, is completely determined by the genome. If the liver fails, it can't chip in and cover for the liver for a while. It can't. It's not genetically able to do that. The only way it can change the way it functions, how it functions, and what characteristics it has is through the gradual process of continuing evolution. The human brain is very different. There are parts of the human brain, especially the subcortical structures that are required for example, to keep you breathing and so forth, that are, their functions are, they are like a heart and a liver and kidneys, kind of the biological equivalent of function-specific machines. They're designed to produce and maintain certain end states in very specific ways under very specific kinds of conditions. At higher levels of organization in the brain, the things we think of when we think of unique human characteristics, those structures, we talk about them, they're not physical structures, but those psychological processes, the emotions, our ability to communicate, our motivations, those characteristics of the brain, they are genetically underdetermined in the sense that they are designed to continue evolving after you're born across your lifespan. And the only difference is that they are continually shaped and reshaped on an ongoing basis by your experiences. And that's why they exist, is to help us deal with things that required kind of moment-to-moment decisions and reactions, things you couldn't, that evolution couldn't have anticipated. So you think of the brain as kind of broadly, you've got these older parts of the brain that we share with a lot of other animals that are essentially genetically, what they're doing is genetically determined. And we have these other higher level processes that we excel in as humans that are not genetically fixed, and they continue evolving during what they call ontogenetic time. And the way that relates back to things like ADHD and depression and so forth is because of this kind of genetically determined processes to the brain and these other ones that are not genetically determined, we are able to design and live in environments because of these newer areas of the brain that the other parts of our brain are not equipped to handle. They're evolutionarily abnormal. There are a number of things, for example, in contemporary environments, there's nothing approximating them on the primordial plane. And those sections of our brain, those subcortical structures, they are preset with certain kinds of response dispositions that will respond to contemporary stimuli. And that contrast is to a degree that's underappreciated and not well documented yet, but almost certainly the case, a major source of the things that we call abnormal mental disorders. Not all of them, but for almost every category of mental disorder, there are probably significant subsets of people for whom their brains are reacting in what we call abnormal ways, but from an evolutionary standpoint, they're functioning exactly the way the brain was designed to function. Because evolution didn't care about how well you felt getting up in the morning and how happy and satisfied you were with your life. It cared about keeping you alive. If you have a near-death experience, a traumatic event happens in your life and you escape death, that has a powerful long-term influence on your functioning from that point forward, absent therapy. And it's the way the brain protected people. Because if you're being chased by tigers on the primordial plane and you escape one, you can either assume from that point on that whenever you hear a noise, it may or may not be a tiger or whatever it was that attacked you. But the cost, of course, of being wrong is death. So the brain errs on the side of caution, not because it was designed that way. It's because the people whose brains didn't function that way didn't survive and pass their genes on. ADHD is a good example. There are the kinds of things that we expect kids normatively in Western society to be able to do are things for which we were not. We did not evolve to be able to read and interpret. Little black squiggles on white sheets of paper didn't exist. We didn't evolve to be sitting in small spaces with many other people for hours at a time. It is evolutionarily abnormal. It's a miracle that we can do it, and it's remarkable that we can do it. It's a great, one of the great features of those parts of the human brain, but it's the other parts of the brain that continue to struggle with it.
So in evolutionary terms, I mean, the concept of normality just doesn't seem to marry well with evolutionary thinking. Like if we try and create a picture of a normal person, that's not really, that's like a full stop to evolution. That's not a carry on point, really. In terms of theorizing about evolution, it seems much more useful to use these terms that I've seen in your writing of equifinality and multifinality, which, if I understand correctly, are the idea that there are multiple pathways to the same outcome, or that you can keep doing the same pathway, and it doesn't mean that you're all going to end up in the same spot. You could actually end up in a different spot using the same.
Right. It's right. The equifinality is that the brain has any number of different resources to draw on to reach any given goal, whatever that goal is. And multifinality is the kind of obverse of that, which is to say that for any given trait can be harnessed in the service of any number of different outcomes. So it's one to many and many to one, which of course, and the origin of that is biological degeneracy. We secrete evidence of this degeneracy, equifinality, multifinality, in everything we do, everything we think about, and no one has to be convinced of it. I mean, a lot of people don't know these names, these formal names for these functioning capabilities we have, but we all recognize them in our day-to-day lives, yet they are completely ignored in the context of doing research. You're probably too young to remember the television ads in the 1980s for Wendy's hamburgers. There was an ad called Parts is Parts, where they were making fun of one of their competitors for making chicken nuggets out of various chicken parts. And the customer wanted to know, well, what are they made of? And he said, well, it's parts. Parts is parts. And in a lot of social and behavioral scientist research, the data points contributed by people they recruit into studies are essentially used as kind of interchangeable parts that are used to kind of construct these models to see how well they fit a particular theory of human behavior, but they are all predicated on the assumption that whatever the cause is, it's the same for everybody in the sample. And it is just demonstrably not true.
I actually started my PhD off in psychology and drifted into anthropology because I found the research tools of anthropology were more fitting the areas that I wanted to study. But one difficulty I had in research psychology, and I've contributed to a number of research projects in psychology, is the lack of ecological validity, or the difficulty of accounting for context. There's often a look at perhaps the structure and the function, but there's often a lack of context in making sense of that data, and it's up to the clinician to sort of pull context in through some form of narrative that they can create in therapy or in the clinic.
The context is not only missing, it is deliberately excluded from the data collection process. The reason being, you know, the standard research paradigm in the social and behavioral sciences is a paradigm that is predicated on several conceits, one of which is that causes of human behavior cannot be identified by studying any given individual. Their behavior is too noisy, it's too variable, and that the only reliable information is if you collect information on a lot of people and look at kind of aggregate level data patterns. Data collection process, and most, I'm talking about psychological research now, is designed to essentially reduce all of the research subject to data points on various measures of things that they're studying, but to essentially strip them of their individuality on the assumption that the statistical algorithms will, whatever meaning there is, whatever is true about the causes of the behavior of the people in that sample, the statistical algorithms will find it out later. If it's real, I'll be able to find it in the data patterns. And the problem, of course, is that all of those algorithms presume that everybody in a given study sample is kind of interchangeable with everyone else. So the two people who have exactly the same scores on two variables, that whatever that means, the computer algorithms will figure it out, and they will presume that those data points mean the same thing for everyone. So the tragedy of it is that that information is deliberately excluded from the data collection process because it doesn't care about individuals. Social behavior and sciences don't study individuals by and large, they study aggregates. So a research subject in an observational study in psychology, for example, a research subject is to a scientist what a confidential informant is to an FBI agent. They are conduits for information about the object of investigative interest, which in the case of social and behavioral sciences research is an aggregate. It's not the individual. The presumption is that whatever is true of the aggregate is also true of everyone that contributed to the aggregate, but it's just layers of baseless assumptions.
The logical flaw that you're outlining here, to my mind, can be related back to the origins of the average calculation, the calculation of the average in the very first place. Aggregate data is useful for population decisions, population-wide decisions, but it's not useful for clinical decisions. And when the calculation for the average was first applied to human populations back in the 1830s by a French or Belgian demographer called Adolphe Quetelet, he took a calculation from astronomy and he applied it to human populations. But in astronomy, it's a calculation used for a single moving object.
Absolutely.
And the logical flaw was then applying that calculation to entire populations of individuals, each with their own characteristics, their own life experiences, their own flaws and shortcomings and strengths and near-death experiences and all sorts of things that get woven into their individual stories and biographies. But there was a logical flaw in doing that. Now, that logical flaw can be sort of okayed if it's for a very specific experimental or demographic reason. But I think that one of the problems here is that idea of the normal, the idea of the mean, the average, drifted out of experimental science or out of population demographics and sifted into everyday society and became an ideal. It became an imperative for people to strive to be the normal.
That's right. For Quetelet, all of those deviations around the mean were kind of, various kinds of accidents of nature, foibles of people, but they weren't the real thing. So you're right. We can trace Quetelet's concept of the average man. We can follow it forward culturally right through the 21st century. And we can take that same concept of homogeneity and you can trace it along a parallel line from Quetelet right through contemporary social and behavioral sciences research. He really is the origin. Well, let's put it that there were predecessors to that kind of thinking, but he formalized it in a way that put it on the map. And you can trace the lineage of our contemporary statistical approaches to studying human beings. You can trace it back through the generations directly back to Quetelet. It's quite remarkable. And most researchers have never heard of him.
It's fascinating how that single calculation has had just a cascade effect on human sciences as well as other sciences. And it's nice to see this movement towards a more complex understanding of what it is to be human, or what life on Earth is, through these concepts which chunk information in different ways. And that's why I'm drawn to these ideas of equifinality and multifinality, what I've seen termed elsewhere as multifunctionality and pluripotentiality. Yep. And in my own research, I turn to the usage of the word by Gerald Edelman and by George Gamow, which was degeneracy. And that's an unsavory term for most people because of the history of that word and the calamity that has created in various places around the world. But we can move forward with new ways of chunking information. And what questions do you think we should ask in order to move forward? Where to from here?
The answer is a radical change. The dominant paradigm now is predicated on, this is nowhere codified. You're not going to find it listed in some book somewhere, but it's there. You can, and you can logically deconstruct it. It's logically implicit in the way this stuff is done, is the assumption that human beings are homogeneous with respect to the internal psychological processes that cause their behavior. On the assumption that that's true, it's the unstated assumption. Most researchers have probably never even thought about it and don't realize that that's the assumption. But if they're stepped through it, they'll say, oh yeah, I see that. But so that if on the assumption that that's true, then the only question is whether or not, in terms of understanding the causes of human behavior, then if everybody is the same qualitatively, so if the assumption is true, then the task for science is simply to find out what combination of variables represents that stuff inside of people that they all share in common that's causing it. If, however, you take that assumption away, it was never justified. No one has ever defended it. It just seeped in the early days, and it's became the mainstay. It's become so fused with the standard research paradigm that it's just there. But if you take that assumption away, then you're not dealing with a more complex task. It radically redefines it. Let's take ADHD or depression, for example. On the current paradigm, everything is based on this tacit assumption of homogeneity. The research is focused on identifying and modeling various combinations of variables that could explain this characteristic, depression or ADHD. But if we admit that the homogeneity assumption cannot, it's not only that it isn't true, it cannot be true. But it just simply can't be, because our brains are designed to keep that from happening. In fact, if we were homogeneous psychologically, we wouldn't be having a Zoom session now. We probably couldn't have an advanced civilization that was necessary to produce this and to be arguing about whether or not we're homogeneous. But if you take the homogeneity assumption away, now the question is, how many different kind of combinations of causal psychological structures do we need to identify? So for any, if you can imagine some hypothetical population of people who by some criteria suffer from what we call ADHD, the question is, how many different kind of combinations of, how many qualitatively different sets of factors would you need to account for the full population? Are there essentially 5 kind of constellations of psychological factors that are different from one another that would be enough to account for most people in the population? Or is it 500? We have no idea. By the way, this I keep referring to ADHD and depression. The same is with the criminology research, understanding the causes of antisocial behavior, criminality, and so forth. The same homogeneity assumption underlies the lion's share of research. The problem is, not only is the task more complex, because if you assume homogeneity, there's only one thing out there, and the question is, what is it? And you collect a bunch of data, you model variables, and you try this and you try that endlessly. But if the question then becomes, all right, how do you go about identifying them? And you can't do it with the existing statistical methods because they are predicated on the assumption of all of their power derives from the assumption of a tacit assumption of homogeneity. So there are certain things you can do with these. I mean, they're not totally useless. For example, by the way, something that was implicit in what you said, and I hope was in mine, that the criticisms that I've been making about the methods are not, there are certain legitimate uses for these statistical methods when they're used for descriptive and predictive purposes. Because if you're just describing a population or trying to predict something in the insurance sense, who is it more higher and lower risk for having some kind of an outcome, if we think of that medically? It doesn't matter for those, for many descriptive, purely predictive purposes. It doesn't matter. All it matters is the thing that you're keying on. So nothing that I've said about homogeneity undermines those uses, but the fact is most uses of these methods appear to be purely, on the surface, to be purely predictive, are not. They're really predictive, and they're using prediction, relative accuracy and prediction as a rough index of whether or not they're theoretical. So they're using it for causal purposes.
One interesting thing I've seen, and one thing I really like about what you're suggesting, which is if we remove the homogeneity assumption and perhaps work from a heterogeneity assumption, then it shifts the kinds of questions we're asking. And what's really interesting about the homogeneity assumption is the way in which research has gone, oh, well, we didn't quite find homogeneity in that sample. So we need to refine our selection criteria. We need to refine our sampling methods. We need to, and so they've created very discrete sets of data that play to the heterogeneity idea, but have got there through a very long process of refining the homogeneity, the tools of research based on the homogeneity assumption. But moving from a space, the questions that you ask when you make the heterogeneity assumption are about the range of behaviors, the pathways, the equifinality, the multifinality, to my mind, at this point in time, those questions are much more interesting to ask. And so your answer to this question is very perceptive, because you're saying that, well, if we shift the paradigm, we ask a different set of questions entirely. And we're only at the very beginning of asking those questions. And that's an exciting time to be.
It really is, and frustrating too, because there is a natural, and this is normal in the normative sense. You know, science is an inherently conservative enterprise. You know, all of this stuff about the public image of scientists being these, buccaneers, these, independent souls that are, bucking the trend and looking to discover new things. That's occasionally true, but science is most of the time an inherently conservative enterprise, and arguably has to be in order to proceed, to progress. But the downside, and it does have, you look at the natural sciences and you see the payoff. Part of that is a natural inclination to resist questioning the kind of basic assumptions we're operating on. It's why most scientists, as Kuhn pointed out, are socialized by training and practice to simply take up where the prior generation left off, to accept at face value their findings, and to presume, as they did, and their previous all going back, to presume that the kind of paradigm, the methodology they're using is essentially on all fours. It may have some warts, deficiencies, nothing is perfect. So most scientists are not taught about methodology in graduate programs, certainly in psychology, social behavioral sciences generally, even in medicine, because they don't need it. In fact, it just creates trouble for the science. So they're not taught about this stuff. They're discouraged from talking about it. And if they start questioning the kind of fundamental assumptions of the paradigm for very long or very loudly, they become, almost by definition, not members of that research community. So the resistance is powerful, and the tendency is overwhelming to assume that any kind of problems, methodological problems, are probably fixable by tinkering and refining what we currently have for methods. And in the case of this homogeneity, it's not true. But the tendency to believe that is overwhelming. And that is the challenge ahead, to get people to stick with it, you know.
I share your frustrations, and I've certainly, you know, like, it wasn't an easy decision to leave a year's work of my PhD thesis behind and move into a different discipline in order to challenge paradigms, because it is hard to, you know, you are.
Getting back to our initial discussion about you know, the route that I took to where I am, where I got, it probably is not insignificant that I went directly from graduate school through a series of coincidences, just great luck and so forth. I went directly from my graduate school. I got my PhD, and 3 months later, I was working at the NIH, which is a federal agency, and that was my career. I worked there for 22 years. I had a number of advantages there because I had a special kind of an arrangement. But one of the advantages is I didn't have to do what most scientists have to do to get tenure and so forth, and that is I didn't have to chase grant money. I didn't, which is, unless it's a purely teaching institution, that's a coin of the realm, is how much, not just what your scholarship is, but how much money are you bringing in. I didn't have to worry about that. And I often think about, if I had gone the academic route instead of with the government, and I had to worry about justifying my existence by getting grant money, and I was therefore, the only way to get grant money is to be formulating research proposals that conform with a paradigm, would I have actually ended up taking on the paradigm the way I did? Because I had wrote my first critical articles while I was still working for the government. They didn't like it, but they didn't. I had essentially a job for life. They had, you know, you have to know somebody to get fired from the federal government. You know.
It's interesting how in that story, which isn't just a story about your fortunate circumstances, and it's great that you've used those opportunities in very productive ways and in ways that challenge dominant paradigms. That story also highlights that the grant system, which in many ways has been set up to make science and work in science more equitable and the distribution of funds more equitable, but in other ways has ended up reinforcing the model of science that Thomas Kuhn wrote about in his book. Is it The Structure of Scientific Revolutions? Is that his book?
Yes. Yep.
Where each generation of scientists just proximally expands upon the work that's been done before them, rather than challenging the paradigms and making entirely new discoveries. Dr. John Richters, it's been an absolute pleasure to talk with you on the series Idioms of Normality, and I've really enjoyed chatting with you, and thank you for your time.
Thank you very much, Paul. I enjoyed it.
And if you're at home listening and watching, please don't forget to like, share, and follow. There'll be lots of great conversations with other people and specialists in all diverse fields. We're going to be looking at the concept of normality in psychology, the concept of normality in conservation, and in other areas as well. And so stay tuned and don't forget to subscribe.